So welcome everybody to this webinar called Exploring Probability on Polypad from Mathigon. I'm going to switch my screens here. Here I am on Mathigon, mathigon.org. As you may know, Mathigon is free for all teachers and students. I'm really excited to share some of the free tools that we have with you on Polypad. We have courses. Polypad is our virtual manipulatives where we're going to spend the majority of time today. We have activities and then a whole section for teachers. So I'm going to go to Polypad. And here is our virtual manipulatives. This white space I'm going to call the canvas. And we have a panel on the left over here where we have tiles to put on the canvas. You can see we have a number of categories. We have geometry, numbers, fractions, algebra, probability, and data. We're going to be spending most of our time here, and some tools. So in the probability section, I'm going to open the coins, dice, and spinners, and I'll just click and drag to put a die on the screen. On the right here, I'll zoom in a little bit more, and I'm going to make a copy of this. And so a few ways to make a copy on Polypad. Down here at the bottom, there's a copy button. So I'll just copy this and drag it over here. Also, when a tile is selected, you can hit the C button on the keyboard. So I just hit the C button, and here I have 4 dice on the screen. I'll click and drag just to move them over here. There's a randomize button at the bottom, and when I click randomize, they all spin. So you can see there all the dice spin. If I double click on a single one, it can spin it as well. And again, it's really easy to make a copy of all of them. I just selected all of them and used the C button on my keyboard. So there are 2 sets of 4 dice, and I'm going to spin them again. So we have coins, we have dice and coins. Here I will put 8 coins on the canvas. Here's a set of 2 of them, and I'll just copy those and copy these as well. If you have any questions along the way, feel free to put them in the chat. I will answer the questions as we go. We'll also answer any questions you have about Polypad or Mathigon in general at the end. So you can see there, I put some coins and dice on the screen. I can double click a particular object to spin it, or I can select all of them and click the randomize button at the bottom. So coins and dice are super fun. We have spinners. The first spinner I'll show you is the uniform spinner. When you put it on the canvas, it has 5 sections. There's a black circle here that if I click and drag the black circle, I can go from 2 sections all the way up to 16 sections. To spin this, I click the randomize button, or I can double click on the spinner as well. The custom spinner, you can change both the number of sections and the size of the section. So here, if I click and drag one of the black circles, I'm changing the size of that region. If I click on the black circle, you can see the cursor changes from a hand to a plus. And when I click the plus, I add a region. So you can see you can add regions. If you want to delete a region, you just click on a black circle and it can delete the region. And you can make these any sizes that you like. In the geometry section, there is a section called measuring tools, one of which is a protractor. So I can put the protractor on the screen and I can measure the size. Oh, I missed a little bit. I can put it right on the center line of the spinner. I can measure the number of degrees in those sections, right? So that's super fun. And again, I can click all of these at once and spin them all at once, which is just fun to watch. I enjoy seeing that happen. So those are the coins, dice, and spinners. I'm going to give a quick overview of all the probability tools and then share some examples about how to use these tools with students to have them engage in some mathematical discovery and play and sense making. We have a playing card section. And so you can see here, one option is just to put a whole deck of 52 cards on the canvas. So I'm going to just go over here to the deck of cards. You can see that I can select draw at the bottom. That takes the first card off the deck. I could turn it over and see that is the ace of spades. When it first puts the deck on the canvas, it's in order. The turn over button flips over the entire deck. So as I click turn over, what we're going to see here is the bottom card on the deck. You can see that is the ace of hearts. So the ace of spades is on top because when I double click to draw the top card and turn it over, I see the ace of spades. I'll put it back on the stack. And then if I turn it over, I'm seeing the bottom card of the deck. The turnover button flips the whole deck. But I can shuffle it. So now it's shuffled. And now when I double click and draw the top card, I don't know what it's going to be. I can turn it over. It's the 3 of spades. The other feature that is really nice is you can choose any cards you want. Let me do the 3, 4, 5, 6, 7, and 8. And I'm going to select all of these cards. I'm holding down the Shift button to select a number of objects at once. And when I have multiple cards that are selected, the Stack button is going to put them all in one stack. So you can see I have 6 cards in the stack. I'm going to flip the whole deck, and I'm going to shuffle it. And now I'm going to put a new tool on the screen, which is in the algebra section. And this is the balance scale. So I'm going to put the balance scale on the screen here and show you just a few of the activities that I think work really well on Polypad with the balance scale. All of the tile types that have a numerical value can work on the balance scale. So this stack here was the set of 6 cards, 3 through 8. So I'm going to draw the top one and put it over here. This could be a fun a number talk with students, a warm-up at the start of class. I have 2 cards on the balance scale. And now I'm going to go to the dice, and I'm going to put 2 of them on this side of the canvas. So, you can see it's balanced right away. So I know that the 2 cards we have add up to 12. But imagine I didn't put them at 12 and I spin them. We could see that the 2 cards are more than 10. And we could see the 2 cards are more than 7 and so on. It's not going to be less than anything because they add up to 12. At some point, I would ask students to make a prediction of the 2 cards. We know they add up to 12. So we see that one is 8. And now maybe I'd ask them to predict what the other one is. And we see there's the 8 and the 4. I could put those cards back in the deck, right? I could turn both of these cards over and put them back in the stack and do it again. And I could take the stack and shuffle the stack, draw 2 cards, and do that activity again. So all sorts of fun things can be done with the playing cards. Let me keep going here just to show you all the tools. These were added over the summer. We have polyhedral dice. The number that you see here is the number of sides of that dice. So we have 4, 6, 8, 12, and 20-sided dice. And again, when you click and drag, all of those can be rolled at the same time. And these also work on the balance scale, so it could be kind of fun to do something like, let me put these 3 on the scale over here. I'll put this one up here, and the 12-sided dice over here, and the 20-sided dice over here, and spin all of these and ask students to make a prediction. Oh, I missed the 6. Which side's going to be heavier? Any chance for them to be balanced? You could get into some really advanced probability with students. I got a balance. That was exciting. 14 and 14. What are the chances that the 20-sided die will be heavier? What's the probability that the 4 dice on the left side will have more? What's the probability that they're the same, right? So just this one simple activity, really easy to build, can get into all sorts of fun probability exploration with students, into some pretty advanced probability as well. Right? Yeah, how many spins to balance would be a fun experiment. I agree, Norma. That's a great suggestion. And just so easy to put it on the canvas and put the balance scale out there and just go. You could have students take dice and balance scale and come up with their own activity to explore. We have non-transitive dice, which I will explore later on in the workshop, but you can see how these work as well. These are the Grimm dice, and you can see in the picture the number of dots on each side of the non-transitive dice. And there's dominoes as well. All right, so that is a super fast introduction to all of the tools. One of the features that I find really powerful here is the ability to take a tile and make lots of copies of it at once. So I'm just going to zoom out here, and I just want to show you how easy it would be to make 100 dice on the screen. So here I'll just copy this, and I'll make 5 of them. And I copied that to make 10. So there are 10 dice. And if I just go copy and move it down, copy, I'm using the C button and the arrows on my keyboard. There's 50. And I just select all of these and copy them. There's 100 really quickly. And so I think there's great power in students to be able to see the results of 100 dice being rolled. Certainly there are lots of simulators online where you can click a button and it can say roll 100 dice, and you see a graph of the number of 1s and 2s and 3s. But I think for students to actually roll it and see the numbers coming up adds to the authenticity of them, that these are the actual numbers that came up. It's not just some code behind the scenes that they might not trust, but it's truly those numbers that were rolled. In the file section on Polypad, I just want to show you that under the examples and templates, so all of these folders here are my folders, but the first folder in any Mathigon account is examples and templates. Again, I just want to emphasize this is free for all teachers and students. I'm logged into a Mathigon account, so I have Polypads in my library. You don't even need an account to use the tools on Polypad. You do need a student or teacher account to save work and to do a few of the things that I'm about to show you. But just to have students go to Polypad and play around, they don't even need an account to be able to do that. But under examples and templates, there is an example Polypad of 100 dice. So that's there. I showed you it took about 7 seconds to make it, but if you wanted to go to that template, you can as well. The other quick thing to show you, under the tile type, you can see there's a question mark here. If you click on that question mark, it'll bring you to a tutorial page of all of the tools in the probability section. So I'm not going to go through the tutorial page because I'm doing a bunch of that of the instructions in this webinar. But as you explore on Polypad, if you're working with the algebra tiles and you're not quite sure how to figure something out, or the number tiles, there's a question mark next to each of them that takes you to a tutorial page. And then all the way at the bottom, there's a link to a general tutorial on just the tools in Polypad. So these are just how to share a Polypad, how to copy a tile, and so on. So lots of good tutorial links if you're getting stuck. But I want to show you a way that I think these tools could be helpful to have students engage in some probability tasks. And so the first task I'm going to show you might be good for students who are thinking about, the words unlikely and likely and not possible. So I made a canvas. You can see it's in my folder called Probability Webinar, and this is called Probability Vocab. So here's a canvas that I made in my teacher account. And the instructions for the students are to make 4 spinners, so each word describes the likeliness of the spinner landing on blue. And here's a spinner to copy. And so the first thing that I want to show you is under settings, I have advanced options checked. And when you have advanced options checked, this gear, when you select a tile, this gear is going to come up. And on this tile, I want to lock the position of it. What that means is the students can copy the tile, but they can't move it, and more importantly, can't delete it by mistake. So now when I assign this canvas to students, you can see if I try to click and drag, I can't. I can copy it and move it around. I can spin it, but I can't delete it. You can see I'm clicking delete and nothing's happening. So I've locked the position of that tile. So here's a canvas that I made. I have some questions for students to fill in. These question boxes at the bottom, I made using the question builder tool. This only appears if you have a teacher account. So in the top right, you can see that I could go to my teacher dashboard. If when you first made a Mathigon account, you made it as a student, and yours is a student dashboard here, under account settings, you can change it to a teacher account. And then once you have a teacher account, you can use the question builder tool. So I put in the answers to these questions. You'll see in a second when I assign this to a student in my class, these will be question marks for the students to fill in the answer. So I'm going to quickly show you how to assign this to students. Before I do, I just want to share with you that in the teacher page, I'm going to open this link for teachers in a new tab here. And under tutorials, there's a video on how to share and assign Polypads and make classes and link students. So I'm not going to go through all the details of how to share it and make classes, but there are tutorial videos here. And then under the recordings of the past webinars, there's one called Teacher Tools that is a whole deep dive into all of the details of making classes and assigning Polypads to students. So here's the Polypad I want to assign. So I'm going to go to the class feature. I'm in my Mathigon account, and so in my Mathigon account, I just have one class. It's called Math A. In my teacher account that I use for school that's connected to Google Classroom at my school, all of my classes in Google Classroom would appear here, and I would choose the class that I want to assign it to. So I'm going to assign it to Math A. I have one student in my Math A class. That's my daughter. Her name is Emily. So I'm going to swipe over to a new browser in Chrome where I'm logged in as my daughter. So you can see here I am. That's her name, Emily Poras. I go to her student dashboard. That's where I am right now. You can see it says her teacher is David Poras. So she is in my Mathigon class. Again, you can go watch those videos of how to add classes and add students to your classes. I go to her Polypad, and under assignments, there is the Polypad that I just assigned, probability vocab. So now she could go and she can copy this. And she said, all right, I want to make the blue impossible. So I got rid of the blue. She wants to make the blue unlikely. So maybe she'll make the blue really small. And I'm just copying these, right? That spinner on the right, I can't delete. So maybe she does that. Not quite even. I did that on purpose. I know it should be right here, but I just want to share with you what I can see on the teacher end. And likely, maybe she'll make the blue really big. Ooh, you can see when I did that, it changed colors. So kids will have to spend some time figuring out what they want to do to make the blue as likely as possible. So maybe those are her 4. She's going to save it before she moves on. And then here it says change the color of the squares below so the chances of picking a blue square match the label. So this would be impossible, would be 0 blue squares. And she types that in and gets a check mark because she got it right. But we also have to make these all a different color. So maybe she'll make those here. This unlikely, so maybe she'll change the color of these. I'm not going to go through the whole thing. Here, this would be 8 blue squares, right? And she could change those colors. This would be 16. And notice when she gets them all right, confetti comes down on the screen. So on any canvas where there are blank question builder boxes for students to fill in, when they get them all right, they get that effect of the confetti coming down the screen. I found that my students this past year in 6th and 7th grade, even if they didn't complete a task in class, and I told them they didn't have to finish it, it was just a class exploration, I would hear from time to time from students who would go and complete the task at home solely to get the confetti. And they were really motivated to get that confetti, which was great. It brought them back to the Polypad to continue their work. So now she'll hit save, and I'm going to go back to my teacher account, and under class, I hit this arrow to reload. I'm going to turn on student names, and you can see in the teacher dashboard, it shows the assignment and then her work. Yeah, I can discard that. So there's her work. And so I could have a conversation with her about her work. Imagine I was doing this in class. All of my students' Polypads would be here. And so I might want to have a conversation with her and with another student to talk about the size of their unlikely region. Maybe there was a student who had their region like that, and we could have a good conversation about the differences between unlikely. I might want to have a conversation here with her about the number she left blue in unlikely versus the amount of blue in the spinner, right? If I was doing this in class and I did not want to show all the student names, I could turn those on and off, right? So a good rich class conversation could be had here. Again, if we had all the student canvases, I'd be thoughtful about which ones I wanted to share with the class and so on. So that's an example of how to use all the tools on Polypad to help students make sense of these descriptors of probability. I'm seeing in the comments that even grade 12s will like the confetti. Yeah, even as a 45-year-old, I enjoy, even when I know the answers and I type them in, I still get that little moment of joy when the confetti comes down on the screen. All right, I'm going to keep moving on to another activity that I did in school this past year with students, and I'm going to go to this probability table example. So I found that some of my students, when they first begin thinking about probability, have trouble with the difference between heads, tails, and tails, heads, that those are different outcomes, but really the same thing. It's one of each. So here's a version of a lesson where I think the tools on Polypad could be really helpful. So the first thing I would want students to think about is just what's the probability of getting all heads on the flip of one coin? And certainly my students would know that that's a half by the time they're in middle school. But before they do it, or before we have a good conversation about that, I would assign them this canvas of 100 coins. And I just want to show you where I got this canvas of 100 coins. It was here in examples and templates, but another place where you could find a lot more templates of Polypads with multiple tiles is if you go to the link at the bottom of the tile bar called lesson plans. That takes you to our task page. And our task has close to 100 puzzles, activities, and lesson plans. Here, you can sort by student explorations and puzzles and games and lesson plans and teaching ideas and tutorials. And in this task page, there is one that's called, I'm going to go up to the top. It's called templates. So you can, in that task page, you could search for templates. There's a number of templates in the geometry section. There's a number of number templates. And I'm going to scroll all the way down to the probability templates, past the fraction templates. And you can see here, I'm going to focus today on the coins. There are templates with 100 coins, 100 pairs of coins, and 50 sets of 3 coins. Again, these are really easy to make, but we figured it's a pretty common template, so we have them pre-made as well. So I would first have each student flip 100 coins and have them count the number of heads out of 100. Maybe have them do this 3 or 4 times just to get a good amount of data. And then on their Polypad, maybe they got, 160 of these and 140 of those. And then they could compare their experimental probability to the theoretical probability. We could talk about if they wanted to simplify that fraction or not. All great. And then I would have a conversation with students about what if we go to 2 coins. And so they certainly know one option is heads, heads. One option is tails, tails. And I try to get the first answer out there that the other option is one of each, right? And then they make a prediction about the theoretical probability being a third, and a third. And even if some students are chomping at the bit to have a different conversation here, I want to get this on the board first. And so then I would add in this table, it seems like the probability with 2 coins of all heads is 1/3. And then I have them go to this canvas and have them flip 100, oh, I missed the last one. Flip 100 sets of 2 coins and count how many of them are blue, blue. And it seems like a lot to count, but it goes pretty quick. And maybe they do this 500 times each. And imagine in a class of 20, what's that, 1,000 trials of this really, really quickly. And so I might then on the whiteboard, I might write all of the times of everyone's 500 they got a blue, blue or a heads, heads. And then we'd go back here, oh, wrong one, and put the total class number as the experimental probability. And if we do it, 1,000 times or 10,000 times, this is not going to approach 1/3, right? This will approach 1/4, and it'll have this great moment of like, wait a second, it seems like something's going on here, right? And then I could use the tools. I'm going to use the ruler tool to draw a straight line to continue my tree here and say, well, on the first coin, if the first coin is a heads, what are the options here? And then for those students that are still really concrete about this idea of the first coin and the second coin, I'd go back here, and I think this is really powerful. I can select all of the first coins. I'm just going to I'm holding down the shift key as I select all of these, right? I'm just going to do the first 50 just in the interest of time on this webinar, but in class I might do all 100, and you can see I can flip the first coin. We can say, oh, on that first flip we did get a heads and a star, right? So I'd go to the table and say, yep, there's our heads and our star. And now I'd go flip the second coin. I'm just going to do this first column for right now. And oh, that first column had all heads here. But I could say, look, here's an example where it was heads star, and here's an example where it was heads heads. So I'd go back to my table and say, look, if we got a heads here, we could get a heads or a star. And I think there's a strong connection between what I'm doing in the tree and what students are seeing, in the results. So here, here's a star heads. I want to try to get a star, star. Hopefully we can get one. There it is, star, star. So I'd show students, look, it's possible to get star heads and star, star, and then go back over here. I can just copy these and put them in over here. And for some students who the abstractness of this table is confusing for them, I think making the connection between the table and what's actually happening over multiple trials can be really powerful and help them make more sense of what this table means. Then I'd certainly go back over here and say we could have heads, tails, and tails, heads, and change all these to 1/4, right? 1/4, 1/4, 1/4. Oh, I missed the 4, but you get the idea. And then I might kind of leave it as an open question or assignment for them to explore on their own. What is it? Change this to a 4th here. And some students might predict that this would be 1/6, right? What a great prediction. They see, oh, it's a half and then a fourth and a sixth. Maybe it's 1/6. And then what I had them do, I think this was a homework assignment. I gave them the canvas of 50 sets of 3 coins, and they spun and counted how many of them were star, 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 or heads, heads, heads. And that next day in class, we all compiled our data into a Google Sheet. And this is an example of the Google Sheet. And you can see that night for homework, students did a total of 9,750 flips of 3 coins. And again, they saw, like, as all of my classes collectively, they saw all of the flips, right? Each person didn't see every 9,750. I think I had each student do this like 10 times or something. But because they counted, they believed that their classmates counted, and they saw that of the 9,750, 1,216 of them were 3 stars, which came out to an experimental probability of 0.1247. And as we know, this should the theoretical probability is 1/8, which is 0.125. So then when we went here and made this 1/8, they believed that it was 1/8. And I think there's great power, as I said, in they saw this, right? So it's not a code that was written for them that they then saw a graph of the results. They saw the results and counted them themselves. And I think that builds a lot of trust and authenticity in that these are the right probabilities here. So that's a pretty cool task. And so easy to do, right? So easy just to make this canvas. And, students enjoy doing this. There's times where the virtual tools add value, I think. I've given assignments where I have students go home and flip coins, right? And keep track of their results, or go home and roll dice and keep track of their results. It's hard to get large sets of data by having students do that. And I think at least in middle school, kids feel like flipping coins and rolling dice on their own isn't as advanced mathematically as getting really, really big trials like this. So I think that adds some value there. In every person's Polypad, then go to File. Oh yeah, the templates directly. Thank you. Good question. So there's 2 ways to get the templates. One is under File. There is a folder called Examples and Templates. But the other way that I want to show you, if you go to the tab on For Teachers, so here's the Teacher tab. Lots of ways to get here. There's a link to our task page. So this is just mathigon.org/tasks. You can get that on the For Teachers page, or if under File, you go all the way down under Lesson Plans and you click on that, it'll take you to the task page, which I think is right here. And if you search for template, TEMP, the templates are going to come up. And there's a whole bunch of templates here, not just in the probability section. All right, cool. Let me keep going here. I want to just share with you a few other things on our task page. A lot of these tasks have been written by folks who are content writers at Mathigon. We have one task, use the probability tool. This was submitted by Chad, who is active in the chat here. So I want to give a shout out to Chad and his students. They made a Polypad version of Shut the Box, which if you have played this game before, it's a fun game with students to play. So you can roll the dice. I got an 11, so I would change the color of 11. So that's super fun to play. Thanks to Chad and his students for putting in Shut the Box here. Here are the instructions and an overview video of how to play Shut the Box. One task, this first one here, Ace in the Hole, was new just this weekend by Nat Banting, a Canadian math teacher who has this whole exploration of the probability of picking an ace. So the first exploration is having students see it on their own and come up with their own experimental probability. So you can shuffle the cards and you can draw the first card. Let's see if it's an ace or not. It's not an ace. So, well, first he has students make a prediction. And so this was a non-ace. So I'd put this non-ace box over here. And then I'll turn this over and do it again and shuffle the cards up. And I just shuffled and draw another one and see if I got an ace or a non-ace. I did not get an ace. And I'd continue like this. And then he has he continues in this about what happens if you peek at the top card or not. And so here I could say the probability is 4 out of 16, which we know simplifies to 1/4. And here comes the confetti, is nice. And so I'm not going to go through this whole task. You can go read it. It's a really well thought out, engaging task. I encourage you to go check out and maybe explore with your students. That's Ace in the Hole. And then there's another task called What Makes a Game Fair, written by Seth Howard, who's a math teacher in Thailand, who uses all of the probability tools to explore when games are fair or not fair. And at the end of the task, there are some examples where the spinner is all the sections aren't the same. So that's a good task to explore. Awesome. How can you flip two things at the same time? Yeah, really easy. Let me just give you a quick example of how to flip two things at the same time. So I'm going to go to a new canvas, which I'm in my file category. If I just hit this plus button, I get a new canvas. And so I'll go to tiles, probability and tools. I'll just show you here's a coin and a spinner. Sorry, a dice and a coin. And then I'll put another dice on the screen. So if you click on a single item, I can double click that. Or if you click and drag to select multiple things on the canvas at once, and then click the randomize button at the bottom, they'll all spin at the same time. Awesome. Question, these are different from assigning a Polypad, correct? Yes. Is there an assignment page? So there are two ways. So these tasks that I've been sharing with you, right, what makes a game fair, there currently aren't ways to assign this to your Mathigon class like I showed you with the Polypad that I assigned to my daughter. You could copy the link and share the link with students through Google Classroom or any LMS that your school uses. So all of these things in the task page that are student explorations that link can be shared, which is different than a Polypad that is shared with students. So here's the Polypad that I shared with my daughter. So this is that canvas that I shared, and that I did in the class feature, right? So then I chose her class and assigned it to that class. All right. Great, cool. Let me keep going here. I will come back to some of the questions at the end, but I want to get to some more examples. One thing that some of you might have come to the webinar today is a preview of our data science tool. So I'm now in a preview mode of Polypad that is not released just yet, but coming soon. And so I want to show you in this preview mode. I think I might have lost the preview mode, so I'm gonna go to the preview mode here and turn on my bookmarks. One sec here. And just go to the preview mode and then turn off my bookmarks. Here we go. So now I'm in the preview mode, and I'm going to go to that Polypad for the probability webinar, which was this one, chart preview. There we go. And now go to tiles. Oh, I lost it. Wrong button. There we go. Now go to tiles, and I lost the preview mode again. Let me try this one more time. All right, here we go. View my bookmarks. I have a link to the preview mode here. There we go. And you can see now there's charts and statistics in the preview mode. And if I go to that file, hopefully this will work now. All right, so now under tiles, there's the preview mode. All right, thank you for bearing with me. I think I had it preloaded, but as I was doing a lot on Polypad, I think it got out of the preview mode. So now this is not live yet, as I said, but coming soon. So I have made a table of data based on the Olympics that just wrapped up. Under tools and axes and under charts and statistics, there is a table option. So that is currently live under tools and axes tables. You saw I was doing that in the probability section, but here I want to make a chart of this data. So I'm going to make a column chart, and I just drag this chart onto the canvas. And so it's a blank chart right now. Here's the data that I want to attach to that chart. And as you may notice, when I click on the table, this blue little triangle comes up. It's like a handle, and when I click and drag on it, I can attach it to that chart. And you can see as soon as I do, it makes the chart, right? So it just automatically puts that data into a chart. When I click on the column chart, some options here at the bottom, I can make it into a row chart, which doesn't look as nice as the column chart. I can make it into a line chart, which certainly does not fit with this data, or an area chart, which is not the best way to represent this data, but there's the bar chart. I can double click on a series and I could change this one to that peachish color if I wanted. That's gold, so maybe I'd change that to gold. I could go to the color picker and find the value for silver and make that silver, and so on. But what I also want to show you is there's the grouped chart, the stacked chart, and there's benefits, pros and cons of each of the charts, right? This is the total number. So here, this shows clearly that the number of total medals of Great Britain was larger than the number in Japan, but the way people typically sort the countries is by the number of gold medals. And then I could do it by a percentage, which could show which country had the greatest percentages of gold. So certainly a lot of noticing and wondering. Great conversation can happen here. Here is the data on the most recent top 10 world records in the 400-meter hurdles, which if you were watching the Olympics, you may have known that both of those records were broken in these Olympics. That's why I chose this one. So I could take this and drag, oh, I don't want to do that. I want to get this blue handle and drag it over to the graph. And there we go. And we could have a good conversation. What do you notice and wonder about the gaps between the men's world record and the women's world record? And then the last example to show is just the, I thought could be a good example of a pie chart, the number of Olympics that have been hosted by each of the continents. And so I can make this bigger and make it a donut chart as well. So some features that are coming soon will be the ability to have these regions in the circle graph get the same color as the data, right? It's not totally clear yet which is Asia and which is Europe. I could certainly take the Protractor tool and use that to find which region is the biggest, but that's a feature that is coming soon. And also, we want to be able to have the user change the scale on the axes and potentially not have it start at 0. All right, so these are coming soon. Really exciting. Timing on the release, not totally sure yet. Hopefully soonish. I know, as I just mentioned, there's still some pieces that we would like to have worked out before it gets released. So hopefully coming soon. But thanks for the excitement about those. Awesome. The probability vocabulary lesson that I shared is not part of the preview mode. That's just an example of a canvas that I made for this webinar. It's not in our task section yet, but I will put the link right now in the chat. And so if that's a canvas that you're interested in using with your students, you can just get that and copy it to your account and go from there. All right, I have a few more things to show you, and then I will open it up to any questions. I did just see one question in the chat that I want to respond to. There was a question about the protractor. Can you rotate it? Absolutely. So here's the protractor. You can spin it. You can make it bigger. You can make it smaller. You can flip it. Notice when I click on the protractor, there's a flip option at the bottom. Let me just zoom in so you can see the flip action in motion, and that just flips the direction of the protractor. All right. Let me just share with you one other task that I found the probability tool is really powerful for. So one of the tasks that I've done with students is sort of the history of probability with the French mathematicians Chevalier de Mere and Pascal and Fermat. It's a great story of the kind of the history of mathematics. So Chevalier de Mere was a French, I actually don't think he was a mathematician. He might have been an attorney or something, but he enjoyed kind of dice games. And so the first game that he played with his friends was this game where a person he was playing had 4 dice, and the game was to get at least 1 6 in 4 rolls of the dice. And so the first time I do this with students, I actually have these big green dice in class, and we roll the dice, and the class votes if they want to be going for the 6s or not going for the 6s. And we play a few times and keep track of the results and have some good conversations about who they think is favored to win. And like Chevalier de Mere, a number of my students first think that the probability is 2/3 of getting at least 1 6, because they think the probability of getting a 6 on this one is a 6th and a 6th and a 6th and a 6th. And you add them all together and you get 4 6ths, which simplifies to 2/3. So they think they should win about 2/3 of the time. But we start playing it and they're not winning about 2/3 of the time. So then either in class or as an assignment, I share this Polypad with them, which is 24 sets of 4 dice, and I have them do it a bunch of times, and they keep track of how many of them have at least one 6. You can see I got one there and there and there, and they could count them all up. And I think I had them do it 20 times for homework or in class and count how many times they got at least one 6. And then we put them in a spreadsheet. So this is all of the class's data. All these numbers are the number of times out of the 24 they got at least one 6. And you can see I collected 10,000 pieces of data just from my class doing that one assignment. And at least one 6 came up about 5,200 times. So our experimental probability was 52.15%. And then we spend a class going through how to calculate the theoretical probability of getting at least one 6. And it's a pretty complicated calculation, which I won't go through now, but kids can get there, and I use the tools in Polypad to help us get there. And then I share that after a while that Chevalier de Mer was playing this game with his friends, they didn't want to play anymore because he kept winning. He was the one who was always trying to get the 6s. So he kept winning. So he had to come up with a new game. And the new game that he came up with was trying to roll at least one pair of double 6s in 24 rolls of 2 dice. So this one in class, it was always hard to do because you had to roll a pair of dice 24 times. And so before Polypad, I would give each student a pair of dice and they'd roll them at their desk, but you'd have to have exactly 24. And sometimes I have more than 24 students and sometimes less. So here it was just really easy to do it on Polypad. And they were trying to go for the double 6s. And we talked about how in the first game, his calculation of 2/3 was flawed, right? It ended up being about 52%. Here, he thought he would also win 2/3 of the time because he knew that getting a 6 and a 6 is 1 out of 36, and there's 24 dice here, so 24 out of 36 also comes out to 2/3. Again, that's flawed, but the students kind of went with it, so they wanted to get a pair of double 6s. Here I got one. And we did this as a class and collected data for this one as well, and we did this one 1,600 times or so, and we got less than a half of the time there was a pair of double 6s. And so the story of this is that when Chevalier de Mer was playing this game, he lost over time because it was less than 50%, and he couldn't figure out why, because he thought his probability in the first game was the correct way to approach the first game. He thought the probability of winning this game was 2/3. He won money, so he thought his probability was the correct probability. But then when he went to this game, then he thought the probability was 2/3. He lost money. So he reached out to his friends for help, and his friends were Fermat and Pascal. And that conversation between them about this game laid the foundation for the theory of probability and how to calculate theoretical probabilities. So a good use of the tools to explore the mathematical history of probability, as well as to have students really work with some difficult and complicated probability questions. So that's a fun task to share as well. One other task in the task page that I want to share more for at the high school level, possibly with probability. I'm going to go to the task page here, and it's the Galton Board. And so this task was written by one of our content writers at Polypad. Her name's Ada. And so she has this awesome canvas where students can go through a Galton board on their own. As you may have seen on the task page, a Galton board is this object where all the beads kind of like fall down. It's kind of like Plinko from The Price is Right, and it falls down into the columns according to the normal distribution. And so in this task here, again, I think the tools on Polypad are really helpful to go from watching a student or having a student watch a simulation or having a student like watch a graph get made by data that's being run in the background. And Polypad has the students do it themselves, has the students see the data. And so here's an example of where students could engage with a Galton board to actually do it on their own. So here are the coins. So you take the coins and you flip all the coins. And this tells you if this little tile, it starts here, should it go right or left? So I got heads, star, star, heads. So that's left, right, right, left. So I would start here. I'd go right, left, left, right. I end up in the C bin, so I'll graph this one in C. right? And then I'll take the second one and I'd flip it. And so I could envision all students doing this in class, and then as a class compiling all the results. So what did I get here? Left, right, also in C. I got the first two in C. I'm going to just do it one more time because this is kind of fun too. I've done this a lot, but I still sort of enjoy it, right? It's kind of a nice, engaging activity. What did I get here? I got right, left, right, and there's D. So I could go through as a student, do all 10 of these, and then as a teacher, I could have a big graph on the board, have students share the numbers that they got for each A, B, C, D, and we can make a graph all together as a class of our results. And if you've played around with this, you may know that there's a connection between the normal distribution and Pascal's triangle. So you could go through all the left, and left, right, and make all the possible combinations. Here's a canvas where she has added rows to it. And so here's 1, 4, 6, 4, 1 is the normal distribution, and 1, 5, 10, 10, 5, 1, and so on. You could continue on that way. But then what's really fun is a great extension at the end. I'm going really fast here, but this is in the task page. So you can just go to the task page and type in Galton, and this will come up. Is on this canvas, she has some barriers in here. So there's a blocker right here. So, even if this started here and I got left, you can't go left. You'd have to go right. So some great fun mathematical exploration can be had about what are the patterns when you have a blocker in there. And you can see she has a number of situations where the blockers are in different spots. And so just having students go explore and play around with this and make predictions and share their observations, I think is a really powerful task. All right. Oh, I have so much more to say in the last few minutes, but let me just share a few last things with you. I know there's questions in the chat that I'm missing that I will come back to at the end of the webinar. One game that I've played a lot in class, going back 15, 20 years now, is a version of roller derby. And so you might have played this with students as well. Here's a roller derby board. I typically just do this on pencil and paper. I give students a piece of paper that has this on it. They have 12 circles to fill in, 2 through 12. I roll dice, and if they have a blank circle in the 3 spot, they would shade it in. It's kind of like bingo, and the first to get all 12 of their circles filled in wins. Here's a way you could do it on Polypad. You can see this is just this game board in the background is a screenshot of a, I'm going to unlock all tiles. So this is just an image I did a screenshot of the PDF that I've passed out on paper of this game. I dragged a screenshot onto the canvas, and then I locked it, so now it can't be moved. So here's a virtual version of this game. Students could choose where on the game board they wanted to put their 12 squares. Here's one that I just made, and let's roll it again. And I got an 8, so maybe I would take this one and change the color of it. And so the first student to change all of their color wins. But I would probably do this on paper. It's fun. I have these big green dice I roll around the room. I don't think the virtual tools add a whole lot here. Maybe if you're not in person, this could be a good way to play the game. But I'm sharing this because I then did a version this past year with the non-transitive dice. And so these non-transitive dice, you can see there is this one that is 5 3s and a 6. There's this one that's 3 2s and 3 5s. And there's this one that's 4s and 1s. And what's great about the non-transitive dice, all of these, the sum of the dots add up to 21. But it's non-transitive in each dice is favored against one other, but not against the other one. So if we had more time, I have a whole activity I could share about how I have students engage with these non-transitive dice and figure out, so if I were to roll the red one, which one would I want my opponent to roll, right? If I were going against the red one, which one would I prefer to roll? But after a day of that, what I then did is I made pairs of these. So I did the red and the blue and the red and the green. And this was after playing a few rounds of roller derby with the classic dice. And then I said, what we're going to do is play a version of this game with the non-transitive dice. And so a number of my students who have played a lot of dice games over the years, they knew that in 2 dice, 7 comes up more than the other numbers. So they sort of had a intuition about where to put in the 12 squares here, or on paper the 12 circles. But when we went to the non-transitive dice, they didn't have an intuition. And so here they had to actually make the probability tree of all the pairs of dice and count which number is going to come up how many times. And they were really invested and motivated to do it because they knew that what we were doing was playing a version of roller derby with the non-transitive dice. So I took these first dice and I spun them, and if they had, an 8, they filled in an 8, and then I rolled these, and if they had a 10, they filled in a 10, and if I rolled these, they filled in their 6. And it was a great, they needed to make the probability tree to find out what are all the options that can come up in pairs of these non-transitive dice. So that was a super fun activity as well. The last thing to show just are some tasks on the task page. There are a number of probability things here. So there's probability. There is a video on compound probabilities. Here's a video of me with a teaching idea of compound probabilities that goes to a simple tree. What's the probability of flipping heads and rolling an even number? And so heads even is 3 out of 12, which is 1/4. But then again, I think there's great value in students doing it. So it should be 1/4. Now actually do it and go count. Go figure out your experimental probability. How does that compare to the theoretical probability? Would be super fun. There's a number of games in here that use our probability tools. So I'll just search again by probability. Here's compound probability. Here's an example where the tools could help students think of multiplying probabilities. Here is the tools on using Polypad. One super fun activity that I put out on Twitter a while ago that seemed to get a lot of excitement from teachers, which I shared kind of at the beginning, is I just put the balance scale on the screen and then put 6 dice on the canvas and had students roll all 6 and try to balance the scale. And this was just a good kind of number warm-up for kids, right? Can you move these dice so the scale is balanced? All right, let's just see here. I could do a 2 and a 2 and a 3, and I think I'm going to do it here, 8 and 8, right? But from kindergarten up to my students in middle school had fun with this task. In middle school, we had great conversations, but is it always possible? And kids quickly got to the conversation, well, if the total sum is odd, that you can't. But then we talked about are all possibilities where all the dice are even, is that going to be able to balance the scale? And so on. So that was great. We have a few games that I've really enjoyed doing with students, the Genius Star and the Genius Square. You may have played these actual games. It's a great board game. I have it at home. I play it in my family all the time. We have permission from the Happy Puzzle Company to have a Polypad version of the Genius Star and the Genius Square. If you want to buy the actual game, I really encourage you to. You can use the code Mathigon for 10% off at the Happy Puzzle Company. But let me show you how it's a good use of the Polypad tools. The way this game works, you would spin all the spinners in the actual board game. It's dice that you roll. So I'm spinning them all, and you can see I got a 48 here. So I take one of these triangles and I put it on 48. I'll do, wrong one. I mean, I could spin them, but I'll put this one on 48, and then this one landed on 22. So I'll put this one on 22, and this one's on 20, and so on. I'm not going to go through it all because we don't have time in this webinar, but all of these 7 gray triangles would be filled in according to the numbers on the spinners. And then you take all of these and you put them on the board and fill in all the spaces that are left. And what's so great about the Genius Square, every possibility has a solution to it. So you can spin these, you can flip them, you can't cut them. So there is a cut tool that's available on the geometry tools, but it is not a valid way to play this game. So I can put this over here and so on. So I assign this Polypad to my students. They just have it in their assignments folder. There are some students just go do it for fun. They just kind of on their own, they'll spin them and they'll just try to solve the puzzle. As a class though, what I do as a class, I'll have this projected. I will spin it for the whole class and I'll tell everyone what numbers we got. They can actually see it. We'll all fill in the same numbers and then have a friendly competition to see who can fill in the star first. What's great about it though, there's often, many of them have multiple solutions. So after a student shares all excitedly that they got it, we keep going and try to find additional ways to solve the puzzle. So that's the Genius Star. I can leave this. It's also the Genius Square is there, which is the same idea, right, with the spinners and the square. All right, so that's super fun. A few other tasks in the last couple minutes that we have, and then I'll stay on and answer any questions. There's a great task on exponential decay, which if you're at the high school level, exponential, like here's 100 dice, and there are some questions about what happens if you roll the dice and you, and you remove all the sixes. So I'm going to roll all the dice, and I'm going to hold down the shift key and select all the sixes and remove them all and do it a few more times. So there aren't a lot of sixes here, so I can do this pretty quick. I got rid of all the sixes, count how many are left, and then spin it again and do the same thing, right? And just have students make a prediction. I got a lot of them there. How many spins will it take to get, 50 dice left? How many turns will it take to get 25 dice left, and so on? Can you model this algebraically? What's the algebraic rule of that? This past year, I had a great time on this activity when I was doing measures of central tendency. In 6th grade, I just did a day where we rolled dice, kids did it on their own, and Pariswell found the mean, median, mode, and range of the dice that they rolled. What's nice about it, to help kids with the median, they could put the dice in order, right, and put the 1s and the 2s and the 3s in order. And then I said, okay, after a few times of practicing this, I said, I'm going to do it again. And I wanted them to make a prediction of the mean, median, mode, and range. I asked them to think about which prediction they were most confident about. If they only had to pick one and they would win a prize if they were right, which one would they predict, the mean, median, mode, and range? We had a good time with that. And then I said, now you have 100 dice. Which one, if you only can predict one, which one will it be, and why are you most confident in it? And that was a good sort of check for understanding. A number of students made a prediction of the range because they were pretty confident a 1 and a 6 would come up. There it is. But there were some students that tried to predict what the mode would be or what the mean would be. And while that was fun to think about how to predict that, it also showed me that they didn't have a great understanding yet of the differences between mean, median, mode, and range, and why the range would be the one that you could predict with the most confidence here. So that was super fun. The final thing, and then I will open it up to questions. I've been talking at you for an hour. I hope there's been some value on this. I just want to give another link to our teacher page. There's an overview of the teacher tools. Here are the current events, or all the recordings of the past webinars that you can see. If you go to our Eventbrite page, we have a number of webinars that are scheduled for the rest of the summer and into the school year. This is where we are right now. We have Back to School with Mathigon focused at the elementary level. I know some of you are already back at school, and then Back to School at the secondary level. And then we are really excited about our guest speaker series coming up for this school year. Interspersed in our guest speaker series will be some Mathigon webinars, one on exploring data science, and then our guest speaker in October is Sunil Singh. Then we have an Exploring Algebra on Polypad, Mary Kemper, behind the scenes, and then our guest speakers continue: Maria del Rosario Zavala, Dan Finkel, Katronia Ag, Desiree Harrison, and Jennifer Sa. So really excited about them, just to share some math ideas with the Mathigon community. So go check those out. If you are interested in more of the tutorials, again, here's the link to the tutorial videos and a link to the Polypad tutorial and all the tutorials in Polypad, which are there. And lastly, not quite lastly yet, under events and webinars, if you're interested in scheduling professional development for your school district, there's a link here on our custom professional development on using Mathigon in schools. And then here's our link to our lesson plan page. We don't send out a lot of emails, maybe about 1 or 2 a month. So we're very, very mindful of not sending out too many emails. But if you are not getting our monthly emails, you might want to go to account settings and make sure this is checked. By default, it's not checked. So if you did not actively opt into our emails when you first signed up to a Mathigon account, this is not checked. A lot of good information in those emails that we send out. Again, it's only about 1 or 2 a month, and we're pretty mindful of not sending out too many emails. And one thing I didn't even talk about today is our courses. A lot of them are in progress, but in the intermediate section, there are some courses on probability. So you can see, I'm scrolling down here, probability introduction. There's a course on, or a chapter on the Monty Hall problem, and randomness and casino mathematics. A lot of this coming soon. We have written the foundations probability course, It's not live yet, but it's the draft is written, so a lot more of the courses are going to be coming soon. All right, again, free for all teachers and students. We're really excited about the new tools we've put out over the summer and some new things that'll be coming out over the next month. So thank you for your engagement in this webinar. I hope it just planted the seeds of some things that you could do with students for this upcoming school year. Please give us a follow on Twitter, tag mathigon.org, and any of the great ideas that you have about how to engage students in mathematics on Polypad. I just put our Twitter handles, mathigon.org, and I'm at David Poras. And the last thing I'll say, I showed you a couple tasks from Chad and Nat and Seth. If you want to contribute a task of your own, that would be really exciting. And on our task page, here's our general task page. We'd love to get more teachers up here. If you search for contribute, why is it not coming up? Here we go. Oh, the contribute task is not there. I don't know. I can find it here somewhere. Anyway, there's a link somewhere on here on how to contribute tasks of your own. So I encourage you to go check that out, and you can learn how to contribute tasks of your own to our task page. All right. I will stop talking about probability here and answer any other questions in the chat. But I'm going to officially end the probability webinar. Say thank you all for coming. I hope this was a valuable use of your time, and I hope you have a great rest of the day. Thanks very much.